In this video, I'm going to talk about how to solve quadratic equation part 2 by completing the square. So there are two goals in this part. Goal 1, recognize the relationship between the coefficient and the constant of perfect square trinomials. This coefficient to be this constant. Goal 2, write the equation of the parabola in vertex form by completing the square. Let's go to next slide. So before we solve the questions, so there are a couple of key ideas we should master. So look at here, s plus 2 square is factor form, right? And if you expand it, this x squared plus 4s plus 4 is perfect square. So look at this one, perfect square, b equals 2, right? Let's get a pen. B equals 4, sorry. B equals 4, and this b, right? And this constant, the constant, see, constant is 4 divided by 2, and the square is 4, right? So if x plus b squared, if we look at here, equals s squared plus 2bx plus b squared, right? We expand it. And then x plus b over 2 squared equals b squared plus bx plus b over 2 squared, right? So you see the b divided by 2 and squared and make a complete square, right? Here 2b divided by 2 equals b, this constant, right? b squared, and form the complete square, right? So in all perfect square trinomial, the constant term is half of the coefficient of x term squared. Remember, constant term, like b squared is constant, b over 2 squared is constant, is half the coefficient of x term, like x term is b divided by 2, right? It's half. And here is b squared, this b is half to b. Here is 4, right? It's half to b squared, half b is 4. To create a perfect square, including x plus bx and no other terms, with variable, we add b over 2 squares, just half b, right? To create a perfect square that includes as squared plus bs squared, and no other terms with variable, factor out a, and then create a perfect square that includes s squared plus bx, right? So let's look at an example, right? First, this is 3s squared, right? A not equals 1. We factor out 3 and s squared minus, this should be 2x. And then we continue to this. This is turned to x squared plus bx, right? 3x squared, right? And minus 2x. In order to make a perfect square, we have to plus negative 2 is b, and divide by 2 squared, and minus same 2, negative 2 squared, right? So yeah, make the balance. So and then you continue. So s3, x, this one is x is 1 square, right? S minus 1 square, and times this 1 square times 3, right? So this is vertex form. Okay, let's jump to the questions. Okay, the first question, write y equals s squared plus 6s plus 2 in vertex form, and then graph the relations. So look at these questions. This is standard form, right? So let's write in vertex form. We have to create a perfect square. So we copy y equals s squared plus cx plus 2, and then s squared plus 6s create a complete square. We have to add 6 divided by 2 is 3, right? 3 squared. And then we add, and we have to subtract 3 squared plus 2, right? So this is a perfect square form, x plus 3 squared. And this minus 9 plus 2 equal, and should be negative 7. So this is vertex form. That's what we want. This is the question asked you. So the vertex should be negative 3 and negative 7, right? So and x of symmetry, so should be x equals negative 3, right? That's the equation of x of symmetry. So we know vertex, we know x of symmetry. And the third, we can find out y-intercept. Y-intercept means x equals 0, so we substitute x equals 0 for x. So, and 0 plus 3 squared minus 7. So 0 plus 3 and 9 minus is 2, right? This is a y-intercept. So that's the graph. So the roughly, right? So this x-axis is y-axis. So the first draw the vertex, negative 7, negative 3 and negative 7. So here is negative 3, and 1, 2, 3, 4, 5, 6, 7. Here is vertex, right? This vertex. So the parabola should pass the vertex. And this is s equals negative 3, right? This equation for x symmetry, right? So we know the y-intercept here for this one, these two, for example, this one. So y-intercept means x equals 0, right? 0 and 2, right? Right now we have a 2 point. We can find out corresponding point and locate in the work and the parabola, right? So and this is x symmetry, x equal -3. This is 0, right? It's x equals 0. And here we don't know, right? So we can set x. So and the same way, right? Same way. But how to find it? So we know -3 is middle point for these 2 points, right? -3 equals x plus 0 and divide by 2. So x equals -2. So here is -6. Sorry, it's -6. So this one should locate on the parabola. So we just draw something like this. Okay. So this is a graph, right? So vertex and x of symmetry as equation, and y-intercept, we can find another point. Use this formula, right? So yeah, this for this question. Let's jump to the another questions. Okay, this question is a word problem. So okay, let's look at this problem. So okay, do remember for the word problem we have a couple of steps to follow. And first read aloud, right? Read aloud. So let's read the whole question. Cassidy's diving platform is 6 feet above the water. One of her dives can be modeled by equation d equals s squared minus 7x plus 6, where d is her position relative to the surface of the water, and x is her horizontal distance from the platform. Both distances are measured in feet. How deep did Cassidy go before coming back up to the surface? So after we read, we know basic ideas for this question, and second one we can draw a picture, right? And draw roughly. So its diving platform is 6 feet above the water, so we can drop some water somewhere here. This water, okay, and then have a platform. Platform should be above the water. For example, this is platform, something like this, and is a person diving, right? Okay, so and we draw the picture, and then 3. And what question asks you to find? What the questions? The question asks you how deep did Cassidy to go before coming back up to the surface. Look like so it's Cassidy diving and then jump into the water and go somewhere, right? Go somewhere. It means how deep, right? If Cassidy is here, how deep? So look like we find the distance here, right? Beneath the surface, how deep? Okay, 4. List what is given, right? The given, so look at the question again. This change another color, and this important relationship, right? D equals s squared minus 7s plus 6. D is position relative to surface. X is horizontal, right? So okay, that's the list given value. And next 5. So we solve it, right? Solve the question. Solve the question. Let's copy d equals s squared minus 7x plus 6. Okay, so this is a standard form. So for this question, so it's asking you how deep. Deep is the point, right? So it's look like we are going to convert the standard form to vertex form, find out the minimum value, right? The deepest point. So we have to create a perfect squares and convert to vertex form. S squared minus 7x. Okay, and then in order to make create a complete square, so here should be divided by 2, right? -7 divided by 2 square, right? And because you subtract, you add it, and you have to subtract, right? So actually, it's the -7 minus divided by 2 should be 3.5, right? And negative square, right? Square, okay, plus 6. So see this perfect square x minus 3.5 squared and minus 3.5 squared plus 6. So that's the calculator. So use the calculator to calculate. So okay, 3.5 squared, 3.5 times 3.5 and equals, and into negative and plus 6, right? Plus 6. Okay, equals negative 6.25 equals negative just 1 second. So this should be 1.625. It should be plus. Negative. Sorry, negative. Let's erase it. negative, right? Should be negative. It's not positive because 3.5 squared is bigger than 6. Okay, so this is vertex form. So it's a 3.5, and this is x vertex s value is a negative 6.25. Okay. Yeah, look at this vertex. So because a equals 1, right? A equals 1 greater than 0. So it's a parabola open upward. We have minimum values. Minimum value should be y value of the vertex, right? So negative 6.5, so which means should be here, right? Negative 6.5. This is not negative because it's negative means beneath of the water surface. So it should be 6.5, right? 6.5. So the answer is 60.5 feet. Answer is feet and meter of the feet. Look at horizontal dimensions. Should be meters or feet, right? 6 feet. 6.5 feet is beneath the water. Okay, how deep? So it's 6.25 feet. Okay, let's move the next question. So this is same thing, same word problem. So let's read left first. Christopher threw a football. Its height h in meters of t second can be modeled by h equals negative 4.9 t squared plus 11.76 t plus 1.4. What was the maximum height of the football and when did it reach the height? So we already read aloud. So draw the picture. Draw the picture. Christopher threw a football, right? So for example, here is yeah, this Christopher throw football, right? This football is bigger, right? So the football throw and go up and go down, right? Go up. Okay. So this is a picture. And the 3, what question asks you to find out? What was maximum value? Maximum. And when did it reach its height? So maximum value means this parabola is open downward, right? So it's when did it reach its height? Because 1 means the time, right? Time. And then maximum value means h. Maximum h. So look like, yeah, it's ask you to find out vertex, right? So because it's a less than 0 should be open downward, so we have maximum value. So these questions to determine maximum value. Okay, let's copy question. H equals negative 4.9 squared plus 11.76 t and plus 1.4. So the same thing, we have to create a perfect square. So first, you know, t squared. Okay, so we have to factor out the negative 1.9, right? 4.9 t squared and minus, right? So it's 11.76 divided by 4.9 t, right? We leave 1.4 outside. So here, so 4.9 t squared. Let's find out 11.76 divided by 4.9. So let's go calculator and 11.76 and divide by 4.9. 4.9 and equals, we put negative, right? Okay, so it's 2.4. So minus 2.4 t plus 1.4, right? 1.4 here, okay. And then go 4.9 and the inside t squared and copy 2.4 t. And in order to make a perfect square, we have to plus 2.4, negative 2.4 squared. So actually 1.4 squared, right? Because half. And then after your minus, you subtract, you add, sorry, and you have to subtract 1.4, negative 1.4 squared. And then 1.4 is outside. And continue 4.9. And this is a perfect square, right? Perfect square, this squares, this negative become positive. So it's t minus 1.2 square, right? And then minus this 1.2 square, 1.2 square, 1.44, right? So it's a negative, negative should be positive. So 1.44 and then times 4.9, right? Plus 1.4, right? So it's this negative. So this should be positive because this add, this minus. Okay, cool. So continue 4.9 t minus 1 point squared. So we do this. Okay. We use calculator and 1.44 times 4.9 equals and plus 1.4. Okay, so equals 8.456 plus 4.456. Okay, this is vertex form. Its vertex is 1.2, 8.456. Okay, so 8.56 is maximum height of a football. So here, maximum, right? And at this time, time should be 1.2 seconds. So when the ball reaches the maximum height, at that time, the time is 1.2 seconds. Okay, so we solve this problem, right? So what is maximum height of football is 8.456 meters. When did it reach this height? After 1.2 seconds. Okay, let's do the summary. So a quadratic relation is in standard form, y equals s squared plus bs plus c, can be rewritten in equivalent vertex form, y equals ax minus h squared plus k, by creating a perfect square within the expression and then factoring it. This technique is called completing squares. It's a very important statement. When completing square, factor out the coefficient of s squared from the term that contains the variable, then divide the coefficient of x term by 2 and square the result. Remember, b divided by 2 and squared. This tells you what must be added and subtracted to create an equivalent expression that contains perfect squared. So when you add it, you have to subtract and create equivalent expression. So that's why we added squared and minus squared. Complete square can be used to determine the vertex of a quadratic relation in the standard form. Okay, so go next. So here I put two word problem in here. So if you're interested, you can do by yourself. I already put answers here. So yeah, that's very good. Thank you for watching.